In this section, we are going to be talking about atmosphere. So, we have different parts of the earth and world around us, like the geosphere is like the earth we live on, or the hydrosphere is like the water. Well, today we're going to be talking about the atmosphere. And in your book, there's this awesome little chart about what the atmosphere is composed of. And as you can see, like the main composition here is actually nitrogen. Nitrogen is the biggest one. And in fact, if you had to rank the gases from most abundant to least abundant, you could use this little chart here. So the most abundant is obviously going to be nitrogen, and then with 78%. And then oxygen with 21%. And then what would be next on this chart? The next biggest piece of pie after nitrogen and oxygen. It would actually be this yellow one, which is water vapor, which can go from 0 to 4% because there's different amounts of water in the air. It's not always the same. And so you could assume it's a probably water vapor, and we'll say on the high end it's 4%. And then after that, on the high end, we have argon, which is almost 1%, 0.93%. And then after argon, you could look at CO2, and then you could look at trace gases. So very little of that. Now, CO2 is the thing that, excuse the pun, becomes a hot button topic with people always talking about global warming. And that seems to be like a really hot button issue. Um, but I want to explain basically why people care and how it matters. So, as CO2 has basically increased, it's actually gone up the last like several years from um, 28 thousandths of the atmosphere to 0.38. So that is like about a 50% increase of what it was before and in the last 150 years. And as that cycles through, basically it doesn't just go nowhere or just up into the sky. It does sink back into the oceans. It has slightly acidified the oceans. That's killed off some little things, not the big things. At first, it tends to kill the little things, but then up the food chain is where that tends to matter. I want to point out something else that I think is extremely important, and that's ozone and how it works. So, ozone is this awesome layer that actually absorbs a lot of the radiation from the sun. So, in the sky, we have the sun with its solar radiation pointing down on us at all times, and it truly is like a giant nuclear bomb in the sky. And if you were near a nuclear bomb, especially that large with no protection, clearly that radiation would cause major problems in your body. So, why is it not bothering us, or it's not bothering us that much? Well, that's because we have something called the ozone layer, and the ozone layer actually absorbs a lot of the radiation from the sun for us. Now, there's still some sun radiation problems when people get sunburns and skin cancers and things like that, but the ozone is there to protect us to a degree. So, ozone, normally there are oxygen molecules are in pairs, but when they're exposed to that extra energy of UV light, they can actually combine with a third oxygen atom and become O3. And that O3 is what can handle a lot of radiation and absorb it for us. And O3 is actually ozone. But there are some chemicals, for instance, CFCs, which used to be in a lot of aerosols. It's been banned in the United States for many years now, but it persists in our environment, and there are other foreign countries that are still using it. And when CFCs go up into the air, they can actually be broken down by UV light and release a chlorine, and that chlorine will go and break up these ozones. So the chlorine from the CFCs actually break down our ozone, so we don't have this protective layer from the sun. So ozone actually gets will absorb quite a bit, and you can see from this chart, so basically, if the ozone layer is here, the intensity of the light as it comes down is less and less and less and less as it goes through the ozone layer. So if this is the ozone layer here, you can see how much gets absorbed. Well, if our ozone is really thin over here, it's not going to be able to absorb as much of this light. Or radiation, I guess I should say. So there's different layers of our atmosphere, and I'm going to go on this picture while I talk about it. I'm going to zoom out a little bit here so we can get a little more of the picture. So the bottom layer is called the troposphere, and this is the sphere that is right next to us on the Earth. You'll notice in the troposphere that as you go up in height, it's only about 10 kilometers wide. It's not very wide, is the troposphere. This is where we live, and mountains and helicopters fly and birds fly in the troposphere. And as you increase in height, the temperature actually usually decreases the higher you go, which you know that as you go up into the mountains. Also, there's this tiny little pause right here at the end of each layer. There's this tiny little pause, and this one's called the tropopause, and this is the stratopause, and this is the mesopause. And that is just an area where the two spheres are kind of mixed a little bit. Just like you go down in levels of water and you have different thermoclines, like different temperatures of water don't tend to mix as you descend in the ocean or descend in a lake. Just as you can feel those layers, the same layering, and it doesn't really mix much, happens in the atmosphere. So there are these distinct layers that are just there because of different temperature differences and pressure differences. So the next one, next layer is called the stratosphere, and that has our very, very important ozone layer. And in the stratosphere, basically temperature will generally increase the higher you go. So it's kind of opposite. And again, this one is so important because this is where ozone blocks radiation from the sun. So this is a very important sphere. The next one is called the mesosphere, and there it temperatures tend to decrease with height, and that's because there's a huge pressure release there, and there's just not that many molecules there. The next one is the thermosphere, and there we are talking about really high, gets very, very hot because there's just not much of a protective layer at all there. And then the last one is the exosphere. The exosphere is what you could look at and call, outer space. It's kind of where the atmosphere ends and space begins. So as you go up to quote outer space, there's no distinct spot where that happens. It just you get so far away from the earth that you're not near many molecules. And what holds this whole atmosphere to the earth? Basically gravity. Gravity is pulling all these molecules down and holding it to the earth. Um, the next thing that I wanted to talk to you about was the radiation. Can I go to a good picture for that? Okay. So, radiation is basically transferring energy, but in waves, electromagnetic waves. So, we have this cool picture here. And if this showed up as a test question, an important answer would be, where does all of the energy come from for our planet? It would be the sun. Okay. And some of that, as solar radiation comes down, and those are like the orange arrows. And then these red arrows, some things are reflected back up, and that would be infrared radiation. That would be radiation through um, waves, essentially, through our Earth emitting some radiation off. So, yes, our Earth actually emits some radiation. And this going bouncing down and going back up. Can you see how this arrow's going up, but this arrow's coming back down? This is actually called the greenhouse effect. Some of the light comes down and stays in, and some of it just is bounced back and forth between the layers. So it stays in there. Okay, so there's a few different ways that heat can move. One of the ones that you know really well is conduction. I actually just had a daughter go and burn herself a little bit on like a griddle that we have while she's making some tortillas. And that is conduction. That is heat energy that transferred in through touching something. So the handle of a pan, some are really nice, expensive handles, and they don't get hot when you heat up the pot, but some do get really, really hot when you heat them up. And that's conduction. So, conduction is passing heat energy through touching. The other way that heat energy can move around is through convection, which is basically the heat being transferred through more of a rolling motion, kind of a mixing up motion where it all moves together. So, convection in the atmosphere is actually air masses. Air masses can move up and down through convection and make these currents. And that's really important when we talk about weather. So, the last thing, and we kind of already talked about it, is basically the greenhouse effect. That is the sun giving us energy, the earth radiating some of that back up, but some of it stays down and is absorbed by the earth. So, um, that's it for this section. And remember and look and know how to read some of these for the tests and the answers in the back of the section, chapter section. Take care.